Okay, so let's go forward. And if you remember from the very early briefing session, this was your original goal to control the car through this terminal, simple ASCII terminal, and that protocol that is carrying the information is MQTT. So there will be the MQTT broker, Mosquitto broker, and you will have this client which will connect the broker from the user interface side. So this is your user interface client, and then you will have that ESP module that is going to be the other client. So when you send the commands through MQTT broker, the ESP client will receive those commands and it's controlling the car. And for the other direction, the sensor values will be carried from ESP to your user interface. So from the user interface, you can move the car, turn the car, and the sensor values, compass and LiDAR, you can read from the car. So the communication goes both direction. Command goes through broker to your car, and the sensor values will be read from your car through MQTT broker. But before going that, let's make some trials with your traffic lights. So this will be the final goal, but we have to do some exercises before we can reach that. So this is what we are going to do next. You have created already earlier your traffic light functionality, so you are able to show the traffic light state either red, yellow or green. So this functionality you will have. So now we are creating the MQTT client that will receive a message, and according to message value, that client will show the traffic light color. So when we are publishing the message, TFL, for example, TFL2, it could illuminate the yellow color, and with 1 perhaps the red one, and with 3 the green one, and some combination colors. So the idea is that we are publishing commands, sending commands to MQTT broker, and then we will have a client there which is listening those messages, and when the client will receive the suitable message, it will turn on the certain traffic light color. And there could be also other virtual machines if you are using the MQTT protocol. So then these commands could go through these different brokers, different networks to control the traffic light. So it means that the other team could run this publish command from their own virtual machine or machine, and that will be so that this command could come from ever. So it don't need to be your own one. So some other teams, if they know if you give them the IP number, so then they can control your traffic lights wherever place. This is now the main flow diagram for your client that you are creating. So first you make the initiation setting. So you define what is required for initiate your application, and then we let thread to be running, so it will be continuous checking that are there messages. And the message handler, when there will be these MQTT messages, those will be handled in so-called callbacks. It's like some kind of interrupt service routine. So when there will be a message from the broker, this callback will be called, and then we start to analyzing the message. First, we have to check that is there right topic and some other things. And then we will, if it's okay, then we will take the message, and then we are passing the message. We dig out the right information from there that we required, and according that those commands, we are then setting the certain traffic light on or off. Same like an idea that you were using with your car about serial bus, but now the carrier is the MQTT protocol. So first initiate our software, and then handle the incoming message and passing the message and do something with those values on inside the message. And if you would like the message to working within different teams, then you have to use the same kind of syntax. So let's now agree that we are using the JSON. I think you know already about the JSON format. So what does that mean? So there will be this name value pair in the JSON format. So if we are sending or publish a message, TFL, the topic is TFL, and the message content is the TFL 3. This could, for example, means that we'll put on the green light. If we put number 1, it put red lights on, and so on. So we could agree that this is our message structure, JSON message structure that we are going to use. So first, we receive the message by our MQTT client, and those in the test situation, we can send those messages with the Mosquitto client by this. For example, this is the publish command that we could use this for trial purposes. So we will receive the message that the Mosquitto terminal we have sent from the Mosquitto terminal. Then we are passing that, and then we are setting the suitable traffic light on. So in the high level, the first trial exercise system looks like that. We will have this traffic light terminal running under MQTT subscribing client, and then with the Mosquitto publish client, we can manually send these test messages. So with these test messages, we can verify that our own C++ client is working as it's supposed to be. So let's next see that how we are able to coding this our client. But it is assumed that this traffic light function that you have already from the earlier exercises, week 8 exercises. And for our C++ code, we are going to use this libmosquitto CPP libraries. So that's the library that gives our MQTT functions to be used like subscribe and publish. And behind these links, you could find some examples and more ideas. So if you are not familiar with the MQTT coding, so please go to see first these links before you go forward. this will help you to understand what is happening next. And as mentioned earlier, you need the certain libraries to be available that you are able to go on with the next exercise. I think the Mosquitto you have already, otherwise you was not able to do the exercises, and this libmosquitto you required with the C++ code, and that JSON parser library is required, and this is for your compiling environment. So next code that I'm going to draw are based for that reference code that you will have in the Moodle. So in the Moodle you will have MQTT 0 reference code. So take that code and you can open those source codes. So you should have this main CPP and MQTT receive, and then the header file. So I'm going to use these source codes in the next presentation or in the explanation. So in the header file, there are some definition where for example, the topics has been defined. So incoming topics, outgoing topics. And then this is the IP number. If you use the local host, it is your local IP number that your device is using where you are running this code. And sometimes you might need to define some other IP numbers, but mainly you can run your code with localhost. And then if you remember from the tutorial material, the 1883 is the default MQTT port number. And then we need this client ID. This is the ID that the broker will recognize that who is the subscriber. So you have to try to define this. Each of the you have to define this as an individual. So there won't be same kind of IDs with different teams. So this you need to define random somehow that the other teams won't have the same kind of ID value. And if you go to see the main part, that's in that main CPP file. So here is the main part of the code, and here we are creating the MQTT object. And as an argument we'll give that as the IP number and the port number, and those were coming from that header file, and then we will put that running the endless loop. So after this thread will run forever, and this will initiate the MQTT thread to be running. And if you remember this block diagram, so we did make the initiations in initial settings, and then we'll put this MQTT library thread running forever. And then the library is working in that way that when there will be some messages, activities on the MQTT side, there will be so-called callbacks that will be activated, and then they start to handle the messages. So when there will be MQTT message, this chain will start ongoing. And if you open the MQTT receive header file, there has been class definition or class member definition for those methods that on call will be activated or will be called. So there will be, of course, the constructor, and then there will be these callbacks. First one is on connect, on message, and on subscribe. So when the connection will be okay, this will be called, when we establish the connection to MQTT broker, this will be called, and when the subscription is done, this will be called, and when there will be some messages, then on message will be called. So these are the callbacks that will be activated when something is happening in the MQTT side. What the constructor function is doing, first it defined this keep alive time. It means that how long the session will be ongoing without new messages. Then we will give some information to user that we will start the connecting, and then we'll try to do the connection. And for the connection, we will give this host IP and port numbers and that keep alive time. And then we start this loop. So after this code lines, the MQTT library start to connect the broker, and then these callbacks will be activated. If these next functions will be successful. And this construction and the next code sets are of course from that MQTT receive CPP file. So follow those source file, the reference source files, so you can understand then that what is happening there. So the first callback on the source file is the onConnect. So this callback will be activated, called when the connection is okay. When our client tries to get the connection to server, and when that connection is successfully, then this callback will be called. And in here we are informed it, printing to user that okay, what was the topic, and that's all. So we can inform the user that now we have been connected for this certain topic. And topic, if you remember, that was defined in the header file. So when the connection is okay, this callback will be called. And then this is the subscribe. So when the description is okay, we will inform the user that was successfully. Okay, so that was the initial settings and so on that you have done, and then we will get this description done and unconnected. So now let's see that how we are working with this on message callback, because that's the callback that will start to handle the message, and we're passing the message and so on. We are working with the message. So here's that on message callback. There are only a few lines here. So this will get the message out when the publish client will send the message. This callback will receive the message, and then we can start to do something with the message. And the message will find out is the pointer for the payload, and the payload will contain the message MQTT message part. And in here we are printing the message, so we can show that the user that is the message, and you could also verify from this print statement that whatever was the published message, so the message will be visible on the screen. You can verify that. You can know that it is the right format and so on. So now it's time for the exercise. There was the make file, including in the reference code. So you could now compile the reference code. Remember to change those IDs and these kind of things, which is relevant, which is related for your team, and then you could compile the code. And when the compiling is done, then you remember that how to run that code. So then after compiling, run the code and then test that code. First, you can test that in the same way as you were doing this. You doing the testing for this Mosquitto client. So use the Mosquitto subscribing. So test first again with this Mosquitto client. So subscribe to listening that TST1 topic, and then open the other terminal window and create the publish message to that Mosquitto. So this is only for that you verifying that your system is still working. This first step here is working purely inside the Mosquitto. And when this is working, then go to forward, and then let's try your own subscribe client. So this was the same idea as earlier. So use the Mosquitto to verify that your system is still working and running. So Mosquitto Broker is running. So when you publish something, it appears to your subscribe window. Okay, now let's try that your own C++ client that you just compiled and do the same thing. So now you are sending these publish messages from Mosquitto, and your own client, C++ client, supposed to be receive and get those messages. So now when you present something, it's supposed to appear in your C++ subscribing client terminal window. If your messages go down, your own client is supposed to pick up the same message from the broker. Now our own message is working. We are able to receive the message, and now we're supposed to be doing something with the message. So next we are going to parsing the message. When we have received the message, we try to dig out the required information from the message, what kind of commands there are, and so on. So there will be another video which will explain about how to do the parsing with the JSON, and you have also already studied this earlier. So I assume that you are in this point, you know what is the JSON message and how to work with the JSON message. So there was this name, value, pair, and so on. But if you don't remember about the JSON and how to do that, please go on back earlier lessons and earlier material that you will have about the JSON and parsing the JSON message. So, as the name value pair, now we are doing the first exercise with the traffic lights, and if you would like to get these messages working within the different teams, then you should of course use the same structure, same format. So we could agree that TFL with the capital letters is the command for the traffic lights, and later there will be the compass and LiDAR command. But these prepare to use this later in the final exercise, but at the moment this TFL is enough. And then we could agree that this is the JSON message, and if there is built a GLF, it's referring that okay, it means about the traffic light command, and the value here defines about that which color. And remember that they also, if you are using these real traffic lights, they're supposed to be more than 3 different modes, because some of the lights are illuminating at the same time in the real traffic lights. So next we're supposed to be able to parsing this message, dig out, verify that the command is right one, and then dig out about the value from the command. But now, before adding that parsing functionality to your traffic light client, open a new empty source file, and let's first try with this parsing without the final code, because it might be that there will be too many errors if you try to do all the things at the same time. So now open the empty source code, and let's try how to do the parsing. And here in this example, as you can see, there is the argument in the main function. So it means that we can give this value. When we start our application, run our code, we can give this argument from the keyboard. And here we have defined about we have defined the string. So the JSON in string here, this will contain about that typed input characters or message or string that we will given from our keyboard. And then we define here this object, this reader and value. So we are going to use this when we are parsing out the message. And in here, we are printing that our message that we were typed. So this is for to verify that the typed string is like we assume. So we can see that when we start our application and type the string, so we can see that it was exactly the right string that we were typed. Next, now we start the parsing. In here, we are checking that the parsing is okay, because if it's not the JSON format, it gives the error. So if the string is not in the right format, the parser is not able to do the parsing, of course. So we first check that it is okay. So it's the right format JSON string. And here we are checking that what was the name value pair, what was the name named here. So we check that was the name car. And if it was the car, then we assume that it is the string. So the value will be string. Here we check that is it a string. If it's string, then we are passing that as a string, and then here we are printing that. And here we are checking that is the value integer, and if it's integer, then we are printing that as an integer. And if it was not either of these, then we are printing the error. So here we are checking that there is the name car. Oh, sorry, that this is their name with the car, is their value string or numeric value, integer value. Now let's try that. Is it working? So here I start my application, and here is that JSON string that I will give to my application, and I'll give this car, and if I give the Ford, it means that this is the string. So then the parser find out, okay, the value was string, and it will inform, it will print that it was the string, and it will print that message here. And now you can remove the bracket or somehow corrupt the message and find out that do you get the error message. And instead of float, if you give the value, some number, integer number, then your code will find out that okay, that it was not string, it was the integer. So here we are checking that is it a string or is it an integer? And according that information we are printing either printing the string or the integer out. And by running your application, you are able to verify. Remember this backslashes, this means that when you have this quotation mark, you have to use this backslash, that the quotation mark will be inside your string. Okay, now it's your turn to make the second exercise. So now change that code in that way that you are able to pick some of your own commands, like it will react for the, let's say, the tag my command, and if you give the number, it will pass out the number from that. So try to get that working with your own commands and your own syntax. Okay, now you have tried already how to catch the MQTT messages, and you have also tried how to use the JSON parser. Now your goal is to integrate those codes together in that way that you are able to passing out the MQTT message. And you could still use the original idea for the MQTT message format. So TFL will be the meaning the traffic light commands, and then the number here defines which color you're supposed to be put on in your traffic lights. So if you send from the Mosquitto broker by this Mosquitto publish command, like this message TFL3, it's supposed to be print green. So in here, in this upper screen, upper terminal, there's your own client, C++ client is running, and here's your publish client that you can use for testing to send those messages. So if I send this TFL3, your client will then print that green on the screen. And if I send 2, it will print the yellow. So in here you can use this JSON parsing functionality to dig out that what is the meaning for each of these numbers. So if you add these certain numbers, then it will print out for the certain color. So now try to get those JSON code and your subscribed code to working together. Integrate those in that way that you are able to send the messages, and with the value on the message will define that which color will be printed out. So the block diagram is now like that. So you are receiving the message, passing the message, and you were printing the messages with the letters with the color names But now, as you did have that traffic light functionality done already earlier, now combine also that together. So you are able to receive, you are able to pass in the message, and now add the traffic light code that you have created earlier together. So then when we send now when we are sending these publish messages, we can control your traffic lights. So by changing the number here, your traffic light will react for that. Now the whole chain is supposed to be working. Receive the message, pass the message, and control the traffic light color according to value inside the message. So this is your exercise 4. When you send a publish message from the Mosquitto client, so then your own traffic light client will react for that, and according to value, it will change the color on your screen. So that's the almost final functionality in this subscribing exercises. So, and you can test this by sending publishing messages, and then your traffic light supposed to be change the color according to value. And in the finally, you can put the whole junction working, and you can control this junction by these MQTT messages. And of course, when the other direction is green, the other direction is supposed to be red, and so on. So remember to keep the real functionality of the lights. Okay, but that's for that, handling the incoming messages and how to demonstrate that is work. So this is now the functionality that you should have. So you are publishing messages, and your traffic lights are reacting for that. And there will be the Mosquitto broker and your own subscribing client that will handle the messages. And it looks like in this way, and the MQTT is controlling the state of the junction's traffic lights.